All right, so what the prior slide says, it says in order to find the least common multiple of two or more expressions, now we are looking at adding variables in, we must factor our expressions. So this example, we want to find the least common multiple of these two pieces. So let's go ahead, we're gonna factor them, and then we will be able to find the LCM, least common multiple between the two. So now this left-hand piece, what I can factor out first is a 4, and then I'm left with x squared minus 4. This right here, that's actually a difference of squares, so hopefully you guys are still remembering that. But the x squared minus 4 turns to x plus 2, not 4, x plus 2, and x minus 2. So now I have that 4x squared minus 16 all the way factored out. So now I'm going to go ahead and factor out the second piece. I can factor out a 6 out of the whole thing before I even look at the polynomial. So I pull a 6 out and I'm left with x squared minus 4x plus 4, which hopefully you guys see is a way easier problem. What multiplies to be 4 that adds up to be negative 4? Well, negative 2 and negative 2. So this is 6 x minus 2 and x minus 2. So right now we see that x minus 2 is the only thing they have in common. However, we have a 4 and a 6. Because of this 4 and 6, we actually need to factor out our numerical values, so the 4 and the 6, into primes as well, so that we can then go fully and see that least common multiple. So that gives me 2 times 2, and then x plus 2 and x minus 2, and then I'll kind of separate those, and then 2 times 3, x minus 2, and x minus 2. Now, when we were going and doing the other problems and we found the least common multiple, we grabbed what the other one had, and so we could write what they had in common. So if I had 2 and 3, the other side needed a 3 over 3, and the other side needed 2 over 2. What we need to do in this case is we need to separate. So now that we're here, we need to go ahead and find the product of the highest power of each factor. Okay, what I mean by that is that this side has 2 squared and x plus 2 and an x minus 2. And this side has a 2, a 3, and this is actually x minus 2 squared. Your goal is to end up with the same thing on both sides. So that's how you're going to find your least common multiple. So you need to end up with at least a 2 squared, a 3, an x plus 2, and then x minus 2 squared, because you have a 2 squared over here and a 3 over here, so you need to have both. This 2 is included in that 2 squared because you have a 2 to the first power. So 2 to the second power is your highest power of your factor. Then an x plus 2. You only have one of them, so you only need one. And then on this side, you've got an x plus 2 squared, which that is your highest power of the factor because this side is only a singular. So this is what you're looking for. If I write it out, that 2 squared plus 3 is actually 2 squared times 3. That's 4 times 3, which is 12. So 12 times x plus 2 times x minus 2 squared is your least common multiple. Now this may take some practice, but your first tip, always factor first and then work from there. Now we don't have things put together yet, so we don't have necessarily context, but that is coming next up. But looking at just this piece, this is factoring. In the next example, I'm going to teach you how to go ahead and make sure you have common denominators by using the least common multiple in this way.